Automatic. Addison.
In this tutorial, we will explore memory management and smart pointers in C++. Let's explore memory management in C++ using malloc and free. Understanding memory management is crucial for robotics programming, especially in resource-constrained environments. So we have our code editor open, and let's do a new file, and let's call it memory management example.cpp. Okay, and let's type the following into the code editor. Do pound include iostream, pound include std.lib, and int main, do int ptr, int star malloc, size of int the assignment operator. Okay, let's make sure everything looks good here. Int parentheses here. Okay, looking good. And let's do if pointer equals null pointer. Stood cout memory allocation failed. Okay, and we need to do stood inline. Return -1. And let's do ptr equals 5. And we'll do stood cout value at pointer. Do star ptr stood end L. Okay, and then down below here, let's do free ptr. And we'll do ptr is equal to null pointer. Do return 0. Okay, so what are we doing here? So going up to here, we are this line right here, we're allocating memory for an integer. Okay. And then down here with this return -1, we're returning an error if the memory allocation has failed. Then down here where we're doing the star ptr equals 5, we're assigning a value to the allocated memory. All right. And then we're freeing the allocated memory with the free function right here. And then down here with the ptr equals null pointer, we're setting pointer to null pointer after freeing the memory. So just to recap, so in this code, we are using malloc right here to allocate memory for an integer and check if the memory allocation was successful. We then assign a value to this memory, print it, and finally free the memory using free to avoid memory leaks. Setting the pointer to null pointer after freeing is a good practice to prevent dangling pointers. So now let's run the code. Value at pointer 5. So that confirms our memory management operations are functioning correctly. Let's explore smart pointers in C++, which provide automatic memory management and help prevent memory leaks. We'll look at unique pointer, shared pointer, weak pointer, which are part of modern C++'s memory management toolkit. So let's create a new file called smartpointers.cpp. And type the following into the code editor. Okay, we're going to create a class called sensor. Let's do private. Create our member variable called name and double value. Let's do public sensor const stood string name double value. Okay. And out here, we're going to do name, value. Let's close the curly braces here. Okay, we're going to go to the next line. Let's do void print info const stood cout sensor name comma value. Value stood and L. Okay, and we got it closed out here. Close that out. All good. And let's go down here to int main. Let's do stood unique pointer sensor 1 is equal to stood make unique okay, and let's do sensor temperature sensor comma 25.5. Oh, need the semicolon at the end here. Okay, and come down. Okay. Now let's do sensor 1. Let's see. Here, arrow, print, info. Okay, and so we don't have to type all that gobbledygook again. Let's just copy and paste. Again, I'm going to explain this in a second. Okay. And let's call this, instead of temperature, we're going to call this humidity. Humidity. And then 60. Sensor 2. Stood weak pointer sensor weak. Don't worry, I will explain all of this. Just hold your horses. Sensor 2, say if auto shared sensor equals weak. Sensor dot lock. Okay, let's do curly braces here. And down here, let's do shared sensor print info. And then down here, we're going to do return 0. So how we're looking, how we're looking, how we looking. Okay, so in this code, we define a sensor class that represents a sensor with a name and a value. In the main function right here, we demonstrate the usage of different smart pointers. So we have the unique pointer, make unique, right here. And the unique pointer points to a sensor object using stood make unique. The unique pointer ensures exclusive ownership and automatically deletes the object when it goes out of scope. We then create a shared pointer to a sensor object using stood make shared. The shared pointer allows multiple pointers to share ownership of the object. The object is deleted when all shared pointer instances go out of scope. So make sure you put shared pointer here and make shared here. Made a mistake a little earlier when I was doing the copy and pasting. And now we also have the weak pointer. We create a weak pointer to the shared pointer. Okay, and the weak pointer does not participate in ownership, but can be used to check if the object is still valid. We use the .lock right here, the lock, to obtain a shared pointer from the weak pointer and access the object. Now let's run the code. And this is what your output should look like. This example demonstrates how to use smart pointers in C++ for robotics projects. Smart pointers provide automatic memory management, helping to prevent memory leaks and simplifying memory ownership. They are particularly useful when dealing with dynamically allocated objects and help make the code more robust and maintainable. Thank you, and I'll see you in the next tutorial. Keep building.